At this point in time, there is one set of what I'll call congruence criterion that we know about, and that's the SSS theorem. So the SSS theorem says that if we've got two triangles, and I know this side is congruent to this side, I know this side is congruent to this side, and this side is congruent to this side, we've talked about how that's enough evidence for us to conclude that the two triangles must be congruent. We didn't say anything about the angles, but it's enough information for us to conclude that the angles that also must be congruent. What we're going to do in this video is we're going to talk about a second congruence criterion. There are going to be a total of 5 that we're going to get to before we're done with them all. But these two kind of go hand in hand. So let's switch over to the document camera. All right, so I've got this triangle sitting right over here, and I've got another triangle on this piece of parchment paper. All right, so this is triangle ABC, and this is triangle XYZ. And what we know, and I've marked these on the diagram, I know that side AB is congruent to side XY. I know that side AC is congruent to side XZ. But instead of knowing about the third side, I know about the angle between the two of them. So I know angle A is congruent to angle X. And the question is this definitely enough information for us to be able to conclude that these two triangles are congruent? The answer to the question is yes. And let's see if we can kind of convince ourselves how, if we do a set of rigid transformations, that these two triangles have to lie on top of each other. All right, so the first thing I'm going to do is I'm going to translate this triangle around so that X is lying right on top of A. Okay, and then I'm going to twist it so that XY and AB are going in the same direction. All right, so I've got these two sides lined up right now. So these two line segments are going in the same direction, and they're the same length. We were given that these two sides have the same length. So Y and B really have to be right on top of each other, don't they? All right, so there's one thing that we know about points that line up here. Let's see what's happening on this side over here. So I know that the angle between XY and XZ is the same as the angle between AB and AC. So these two lines are also going in the same direction, because these two lines are going in the same direction, and you're doing the same rotation on both of them to get to where this double marked side is. All right, so XZ and AC must be at least parallel to each other, and X lines up with A. So these two sides definitely have to line up with each other. And the other thing we know is that these two line segments not only are heading off in the same direction, but they have the same distance, because we know that AC is congruent to XZ. So therefore, when I lay this down rotated like this, not only does Y line up with B, but Z also has to line up with C. All right, so therefore, we know that these two sides are congruent to each other because that was given to us. We know that these two sides are congruent to each other because they were given to us. And we can also say, can't we, that YZ must be congruent to BC, because Y and Z are the same 2 points as B and C. And so since these 2 points lie on top of each other, the distance from Y to Z must be the same as the distance from B to C. So after we do that set of translation and rotation, we can see that this third side also must be congruent. So therefore, because of SSS, we can conclude that these two triangles must be congruent. But we didn't start with knowing about the 3 sides. All we started with, and I'm going to write this out carefully, we started out not knowing about side, but we started by talking about 2 sides and the angle that was between them. And just like this angle is between these 2 sides, I'm going to write an A between the 2 S's. All right, and that's important that that's true in both of these triangles. This angle is between these two sides, and this angle is between these two sides. And that gives us the second rule for knowing if two triangles are congruent to each other, which is called SAF. All right, so SSS stands for side, 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 and SAS stands for side, angle, side. And so this gives us another set of rules. So we don't just need to use SSS to prove that two triangles are congruent. We can also use SAS if that's the information that we know about two triangles. All right, I hope that made some sense. So the idea is that now we have an extra tool in our toolkit for proving triangles are congruent. Not just SSS, but this new rule of SAS.